Hey, good afternoon, everybody, and welcome to TGIK number 99. Good to see you all. Let's see who's with us this afternoon. We got Matt checking in. Oh, thank you very much for your words of encouragement there. I'm really enjoying the grokking stuff as well. We got ABC123 coming in. We got Suresh from Hamburg. How you doing, Suresh? And we got Olav from Copenhagen. And the Matty, good to see you, as always. And Gustavo Chavez from Chicago. We got Ramesh from San Francisco, right here in San Francisco. And what are my favorite memories from KubeCon? That's a great question. KubeCon for me was really an interesting one this year, mainly because it was part of just a very busy month. I spent most of my November traveling. I spent the first week in Barcelona at VMworld EU, which was an amazing experience. I got to meet with a lot of people and really get to kind of engage with a number of different efforts across the company that are really like engaged in this new Kubernetes regime stuff, and that was really exciting. The second week I was at an event in Dallas, and then obviously KubeCon in San Diego, which was amazing. I participated in a couple of the 0-day and pre-show events. So I flew in on Sunday and did a talk with my friend Nick Lane. And that was really an incredible thing. It was really neat because it was in this museum that was really all about kind of inclusivity and things like that, which I thought was really a pretty neat kind of experience. Like the Rejects conference this year in San Diego was like held in a museum that was really doing like a whole historical thing about inclusion and the fact that we should all kind of think that's super important. And I thought that was really great. And then during the show itself, I attended the security day, and I really enjoyed, again, speaking with Ian Coldwater. Speaking of which, our talk from Black Hat is up, and I'll give you a link to that here in a minute. And then the main event, 3 days, was just amazing. Like, there were so many people there, and there was so much stuff being presented and talked about that it was really overwhelming to try and get all of it in. I think that everybody had their own kind of unique experience because there was so much going on. But I had a great time. What else? We got Yatin from Ashburn, Virginia, and we got Morteza from Iran. Suresh, yeah, I'm wearing my Tanzu colors, I like it. We got Martin from Netherlands, and we got Ilko from the Netherlands as well. And we have Philippe from Paris. So good to see you all. Sorry, my nose is a little itchy. Still dealing with the very last end of a head cold. And if I'm looking off to my left, it's because that's where my chat is. So you know how it is. Bogdan from Bucharest, Romania, and Ismail from Ankara. So good to see you all. I hope you're getting ready to. This is another one of those things. Like you've heard Joe say this, and I've said it lots of times. I'm always amazed at the fact that we have audience members from just all over the world. I mean, and I'm curious, like, if you want to put information into the chat about, like, whether you actually get time off during this part of the year to celebrate holidays or just hang out with family and friends. I'm curious if that's like a global thing, or if that's I know it's obviously here in the U.S. and that I think it's obviously in Europe, but depending on where you're at, that may not be quite as much a thing. So I'm kind of curious how that works. So. Anyway, if you do get to take off some time, I hope you enjoy it. And this time of year, I really like to spend it with family and friends and that sort of stuff. So let's get started here. This week, we got some really good news to talk about. Obviously, 117 is out, and that is exciting. So this year, that's hilarious. This release is about stability, and so it was really a pretty good, interesting thing. There's lots of changes and lots of things that have come with this release. If you're curious about digging into some more of the stuff that actually came with it, there's a link here to the community retrospective with regard to the release itself, and this is folks talking about how the release went, like what it was. What we learned from it, what we thought we could improve on, that sort of thing. The release 117 already has a regression. It's a performance regression on webhook backend requests. So this is your releasely reminder that just because we've released the next version of Kubernetes, we definitely want you to kick it around and test it out. And I mean, like the feedback that we get from the community around a new release is actually incredibly valuable to all of the people working on it. But at the same time, I wouldn't necessarily move your production clusters to the very freshest release. I would definitely say, wait for a few dot releases and let us catch those things that the brave souls kicking up brand new versions of Kubernetes have discovered. So really helpful stuff. But that regression has already been picked up, so that's pretty great. Speaking of how can you get your hands on 117 in a safe way, I spend a good amount of my time in these sessions exploring Kubernetes with Kind, and we're going to do that in this session as well. And so Benjamin Elder, who's one of the architects of Kind, he actually put up a new node, the Kindest node, version 117.0. And so you can actually spin up a Kubernetes 117 cluster and play around with it and see what you think just by running that command there once you get Kind installed. Pardon me. So if you want to play with it and look at it and see how it works and like try your manifests against it and just explore it, and 117 is out, and you can grab the image tag there. Other things in 117, the Kubernetes podcast is actually got a release out on the 10th of December. And they're doing an exploration of Kubernetes 1.17 with Guinevere Singer, who was our release lead this year for this one, the release manager. Gwen is awesome, like absolutely awesome. So I'm sure that this session is just filled with laughter and awesome things. So if you have time to check it out, definitely do so. Also, a shout out to the Kubernetes podcast from Google, because they do a pretty decent job of collecting news of the week. We do that here as well, obviously, but I thought it was pretty cool that that's there. One of the things that's interesting in the infrastructure space this week, we now have an application gateway ingress controller for Azure Kubernetes service. And I haven't explored this too much, but I thought that was pretty cool. It seems as though it's going to be somewhat similar to the Amazon ALB ingress controller, only on Azure. And typically what that means is that there is a way for you to get traffic from the application gateway back to pods in a more kind of deterministic fashion rather than passing it through a load balancer, right? Because your ingress has to operate at layer 7, and so there's some interesting challenges with that. If we're operating at layer 7 at the termination of an application gateway, that means that we need to be able to keep track of where we sent that last connection. Did we send it to pod 1 or pod 6? And how do we make that routing decision? Typically, when you're dealing with an application gateway, you have to make that routing decision up at the gateway level and make sure that you can terminate directly to the pods, so that you're not making that decision twice, changing and breaking things like WebSockets and stuff like that. So kind of interesting. It'll be interesting to see how that works, but it's out there now. So definitely go, if you're on Azure, go check it out. And, let me know how that goes. I'm curious. I haven't obviously had time to explore it myself yet, but it is pretty neat that it's out there. There's also this actually made quite a bit of an impact on my Twitter feed. I thought that was pretty great. That somebody put up a visual guide for troubleshooting Kubernetes deployments, and it just showed up everywhere. So I thought I would put it up here. And here we have the visual guide on troubleshooting Kubernetes deployments. I have looked at this, and this is actually looking pretty good. If you, some people, everybody learns and thinks about things differently. Like, it's very interesting. Some people are very linear thinkers, and they want a map to allow for that, kind of a check and balance, a checks way of going through that linear thought process for validating things. Some people are nonlinear thinkers, and they want to be able to just have all the information and figure out how to throw it together in their head themselves. And so it's really great to see stuff like this because it really, I think it means that we're appealing to more audiences, right? Like we have definitely people who will find this incredibly helpful just to dig into it and understand how to look into it. So definitely check this out. I was really impressed with how this was put together, and I feel like they did a great job of describing, how to troubleshoot this stuff. What else do we have up on our news this week? We talked about the visual guide. Oh, there's a new version. Oh, sorry, I don't want to do that. Boop. There's a new version of Cube State Metrics out, which is exciting. And Cube State Metrics in this release has a number of new features. Cube State Metrics is a tool that allows you to pull metrics back from all of the kubelets and the control plane components inside of Kubernetes. Since they're all instrumented with Prometheus, Cube State Metrics gives you the ability to kind of pull all of those metrics back and then expose them inside of Prometheus. So in the release, they talk about some of the changes that have come. So there's some new metrics that were not collected before. We have things like Cube HPA spec target metric, the namespace status condition metric. Sorry, talking now is making me sneeze again. We have the persistent volume claim status condition. Lots of interesting stuff being shown up here. So this is a very important project, and I think it's actually pretty cool. So definitely check this one out. And if you're interested in understanding when those things are changing, Tariq is actually now one of the main contributors, one of the release leads, perhaps, the term I'm looking for. One of the people who's in charge of making sure that a new release is cut and going through this, right? And so usually he will announce when there is a new release candidate out. And when there is a new release candidate out, it's really helpful to have people explore it and see if it's working for them and that sort of thing before they cut a new release. And so this is actually a method that this particular project uses to evaluate whether they are ready to ship a stable version or whether they should keep it in another couple of releases. And even in the release notes, if you go to releases here, you can see that there was already another cut right after this one that fixed a bug that somebody opened, right? So people who are, it's actually a pretty good one, a pretty good, interesting way of evaluating an open source project like this, right? So they announce a new release, a new release candidate, and they ask people to come take a look at it, and that's pretty great. So cool stuff. If you're using Cube State Metrics in your Kubernetes clusters, throw a note up into the chat. I'm curious if y'all have seen this before or if it's something that y'all are exploring. If you have used Kube Prometheus, which is a tool that is meant to instrument Kubernetes on top of Prometheus, you probably are using it. You may not be aware that you are, but it's in there. The folks at StackRox actually did a pretty decent article, delivered on the 9th, that digs into some of the new features of 117. So if you're curious about what's coming in 117, this is a pretty interesting thing, pretty interesting article. I think they did a decent job of talking through what's here. Endpoint slice is a big one, and it happened kind of right around the same time as the IPv6 stuff. And so there's a lot of things that were influenced by endpoint slice and in relation to IPv6 and IPv6 dual stack support. So, but it's out there now. It's in alpha. Shout out to my friend Cal, who has done a ton of work on this, and also a number of other people in the community for contributing. Valerie is one of them. There's just a ton of people who've been doing a lot of work to make this work. IPv6 is a big change to the way that Kubernetes works, especially in the dual stack stuff. So I mean, like if you think about it, like even as something as intrinsic as a pod having an IP address, right? Like that seems like a built-in thing. Well, now we have to think about multiple IP addresses as they relate to pods, right? And so there's a ton of, you can think of like all the different places that the code base would have to be touched to be able to support dual stack IPv4, IPv6 addressing as it relates to every part of the network. And so a ton of work. I mean, like a lot of work that went into this. And I think everybody did just an incredible job of moving this forward. Persistent volume snapshot backup and restore support is in CSI, and it's graduating to beta, which is exciting. So if you haven't explored snapshots as they relate to CSI, give it a try if you can, or if you're interested in doing so. And then topology-aware service routing. Now this is also related to endpoint slice. And this one's pretty interesting because it gives us the ability to think about to reduce the amount of work that kubeproxy might have to do in some cases, right? And so it's kind of an interesting improvement. And so it's also the goal to think about how we send traffic back and forth between nodes, given that they might be part of different availability zones, right? So it would give us the ability perhaps to reduce the cost of traffic moving back and forth across the cluster if we're able to enforce that traffic keep within the same topology or availability zone. So interesting stuff happening there. API defaulting for custom resources, which is exciting. Lots of stuff happening for CRDs actually this release. Process namespace sharing in pods, which means that if you had multiple containers in the same pod, that means that if you were to jump into container 1 and container 2 and type ps-ef, you'd see the same output, right? Typically what happens before this change is that all containers have their own PID namespace. Each container has its own PID namespace. But in this model, now we can actually enable you to say that you want to share that PID namespace across all of the containers. And there are some good things about that, and there are some interesting things about that. The good thing is that now you can do things like just check if the process is live as part of a health check rather than having to interact with it. So that might be a good thing. There's some other interesting stuff that happens, especially from a security perspective. Anyway, StackRox did a great job of talking about this. And I have two more things I want to talk about news-wise. Mentioned designing with fault domains in mind. Yeah, this actually does play into that, right? So if you're designing with fault domains in mind, the idea of a topology-aware service routing might be a factor to consider there. We got Mohammed from Bonn, Germany, and we got Amin from Algeria. Olav is telling us that in Denmark, first and second day of Christmas, 24th and 25th of December, and the first day of January. That's pretty true here too. Many people burn some of their 25 annual vacation day. Yeah, that makes sense. Like between Christmas and New Year's, or between yeah. And the sidecar container spec and pod spec is missed in this release. What does that mean? Suresh, do you want to link me to what you're talking about? I'm kind of curious. I think I know what you're talking about because we were talking about a new thing that was going to be called sidecar, which I thought was a little confusing at first, but yeah, like a first-class citizen of what sidecar is. Also in 117, we have ephemeral containers. They didn't cover in this article, but that's also worth talking about. So, the other thing I have for you is 2 shameless self-promotions. And so, here they are. I'm just super proud of this. Earlier this year, I did a talk with Ian Coldwater, and it was an incredible experience to co-present with them. And if you would like to see that talk, it is now up on YouTube. So if you want to go check that out and give me some feedback on Twitter or just DM me, let me know what you thought. I'm actually really excited to see what y'all think. I watched it last night with my wife, who is non-technical, and she thought it was awesome. And so I hope you all like it too. It's been a long time in coming. I think I did this in really early in the year. And now finally it's up. So go check that out. Let me know what your thoughts are. I hope that you find it as useful as I intended it to be. Otherwise, we'll see how it goes. Another project I've been working on, and actually this is a VMware project. So it's not just entirely shameless self-promotion, but promotion of a number of my colleagues as well, which is exciting, is a project called The Podlets. And it is a podcast that we do every week. There are 7 episodes up, and these episodes are generally just kind of exploring the area of Kubernetes and cloud native ecosystem. not too dissimilar from TGIK. We try not to, in the podcast, we try not to delve into particular solutions, but more to expand the awareness or understanding of particular problems as they relate to this whole ecosystem. So if that's something that you're interested in, check out the podcast. We were very, very honored to have Kelsey Hightower on it just last week, and that was super exciting. We've also recorded a session with Mr. Joe Beta, of course, and and a number of other sessions with other members of our team like Josh Rosso and Carlicia and just a ton of other people. So go check that out if those are interesting to you. And now we're going to get back into the crazy part of the show notes. All right, so this is TGIK, so there's been a bunch of them. This is the Grokking series. There's been a bunch. We started with the kubelet. We went to kube proxy. We talked about controller manager. We talked about the scheduler. And this episode, we're going to talk about the API server. I'm not totally confident that we can get through the entire API server in the remaining hour and a half that I want to spend on this, but we're going to give it our best shot. So that'll be really fun. So let's get started. To kick this off, what I'm going to do is I'm going to spin up a kind cluster, kind create cluster, and while I'm waiting for that to kick up, I'm actually going to go ahead and talk about like how some of this stuff works, and then I'll show you like on disk where we can find some of that stuff to work. One of the things I want to talk about here is this document here. Oh. So this is a flow diagram that describes kind of like where the API server sits in the mix of things, and we can see by the number of arrows that are pointed at it that it is on the hook for tons of stuff. And this isn't a complete implementation, but you can see that like a user, when they create a pod, that pod spec gets sent to the API server, and the API server makes a bunch of decisions like pretty much right away, right? Like, is the user authenticated? How are they authorized? Is the thing that the user gave me a valid spec? You know, is the thing that they're asking me to do valid? And actually, is the thing that they're asking me to do permissible? You know, API server has a bunch of other capabilities, like the ability to mutate that object or to validate that object in more custom ways, right? You can define business policy or validating and mutating webhooks, and we'll talk more about them. Right here at the API server to ensure that before we persist this object to etcd, that it is in line with our best practices that we've defined. And there are a bunch of different admission controllers that are built into the API server that we're going to also kind of talk about, and that can be used to validate or modify or even convert the object before being allowed admittance into etcd. But fundamentally, we can see, like from the top of this diagram, that the API server is responsible for being that thing in the front for everything, right? When an object gets persisted to the API, when it gets handed to the API server, it goes through all of the process of determining its validate. You know, what we were talking about there, the authentication, authorization, validating, serializing of resources, all of that stuff. And then it gets persisted back to etcd as an object upon admittance. And then what's interesting is that particular transaction is now done. The API server doesn't spend any more of its time thinking about that object once it persists it, whether that object is a deployment or a stateful set or a pod or any of that stuff. Its whole job is basically just to persist that object to etcd and get it through that train of things or tooling that has to be that it has to go through before it can be allowed admittance. But the API server also acts as the only way to interact with that stored object, right? So once we actually have a pod defined, that metadata, that object is, of course, persisted to etcd, but the API server is the only way to get to it or to modify it or to interact with it, typically with regard to the system. Right? As a user, you might use kubekettle to do a get pods, and when you do that, you're interacting with the API server, and the API server is responding with what it knows about that pod. What's the status of it, what the object looks like, that sort of stuff. And this is true, this is the same flow that the scheduler and the kubelet and the controller manager all use to interact with those objects. And as you can, and as we explored the controller manager and the scheduler in previous episodes, you can go down into those episodes and see like what is some of the work that the controller manager is going to do when it interacts with the API server. But fundamentally, the API server is meant to be somewhat stateless in its capability, right? We want to be able to have multiple API servers all talking to the same persistent database in the back end, and we want to make sure that we can scale the number of consumers of that API server pretty resilient, pretty reliably, right? We don't want so we don't want to like have a model where, for example, we lock whenever there's a transaction happening. We want to be able to make it so that persisting that object or completing that transaction is done quickly, and then any further modification of that object can be done out of band, right? And thus this whole loosely coupled distributed system that is Kubernetes and how it works. Thank you, Suresh. I'll take a look at that. But yeah, there's a new thing. There's a new KEP on the sidecar, which I think is interesting and worth talking about. Presumably, it didn't make it into 117, which is what Suresh is saying. But there is a new first-class object that is the sidecar, and I still think that's a little confusing, but it's definitely worth checking out. So yeah, the API server is the hinge upon this whole thing. It is the way that we interact with the state of the cluster, and it is responsible for storing any number of different objects, whether those be the deployment objects, the stateful objects, all of the different abstractions that we've created within Kubernetes. All of that content is stored in the API server and pulled from the API server for those resources that need it. Now, let's dig in a little bit into how this piece would work. So, some of the benefits of this API server model, before I go back to the cluster and we look at like how these things are interacting, are the idea that the API server can also can provide a number of different ways to interact with the objects in the back end, right? They can provide a RESTful API. The API server provides a RESTful API to interact with those things. And of course, it also provides an open API document to describe like what all of the different ways to interact with any given object within the API server should look like. You know, what the fields are necessary and like what optional fields there are. And we're going to explore those as well. But there's also a few different access methods for objects, right? Like you could do a get or you could do a watch. And the watch is really interesting because it lets us do a thing where we connect to an API server and we maintain that connection. And we tell the API server, over this connection, I want you to tell me when anything changes with regard to the resource that I'm watching, right? So if I wanted to do kubectl get pods, and I do you can actually exercise this with kubectl. If you do kubectl get pods -w, you can actually watch as these things change over time, right? So like I'll go ahead and open another terminal here. We'll get mean and delete a pod -n. Boop, boop. Kube system. Bye-bye, Cordianus. And so you can see in the output here that because I'm doing a watch, I'm only notified of those things that change, right? And so this is a different model for interacting with this particular object store than we would normally see in some of the other databases that are out there, right? So we have different ways of accessing data that is presented or that the API server is persisting. right? We have this watch mechanism. We also have just the regular get. Like if I wanted to do kubectl get, I can do that too. So there's a couple different things. And we're going to talk a little bit more about watch and how that works and like some of the load characteristics of that as well. So let's go back to our notes, and we have started to kind of get into theory of operation a little bit. I want to come back to and just boop and start with authentication stuff. So we're going to look at kind of like how the API server itself authenticates to things. Then we're going to talk about how the API server handles authentication to it. Like you as a user, how do you authenticate to the API server? Then we're going to talk about how authorization works, right? RBAC or node authorization, things like that. We're going to come back and we're going to revisit admission control a little bit. Now we've talked about admission control a few times in TGIK, but we're going to explore that stuff. And then we're going to get into exploring the API as it is presented by the API server, like some things that we can look into and see how they work. Like, obviously you've heard me talk about kubectl explain a million times, but I'm also going to show you how to get to that open API document if you want to explore that. We're going to talk about how deprecation works within the API server, and then validating muting webhooks. And then we've already begun this one. We're obviously going to do more there, but I just wanted to kind of get off on the right foot there. So we're going to talk a little bit more about theory of operation, and then we're going to talk about HA, docs, and those sorts of things. So let's get kicked off with authentication to how the API server itself is authenticated. In previous episodes of the Grokking series, I've shown you this as well, so I'm going to just exec into my kind control plane, which is like jumping into the node where my API server is run. Now, inside of the way that kubeadm brings up a cluster, it brings up a cluster by creating a folder called Kubernetes manifests, and it specifies the some static pod manifests that are going to handle the control plane components. And the Kube API server is one of them, right? So if we look at the Kube API server here, manifest, this is the configuration, this is the default configuration that kubeadm passes to the API server. And there are a bunch of really interesting fields here, or a bunch of different interesting fields here, because the API server is so important in the grander, in the big picture of how Kubernetes works. There's a ton of like really important things that happen with the flags. So as usual, if you're curious about getting into the flags and what they mean and how they work, definitely go check out the doc for the API server, right? And so we have that here. We just do docs.k8s.io. Kube API server. Our reference documentation is pretty decent for this stuff, and it really describes a lot of the different flags that you can provide to the API server. So, including things like how many API servers there are, what API audiences that we're going to watch for. I mean, there's a ton of stuff in here, and I'm obviously not going to spend the next 2 hours going flag by flag here, but clearly there are a bunch of things that the API server does that are configurable on the command line. Things like, whether you want to turn on audit logs, and when you do turn on audit logs, do you want to handle the automatic rotation of those logs? And how big do those logs get before you change them? If you're using a mechanism to actually send or emit those events that the audit log might watch, how long do you wait for it to go? So there's audit log stuff. There is authorization stuff. Obviously, a lot of this stuff is configurable. This is one of the defaults that I know that makes Joe crazy, kind of makes me crazy too. This is the authorization mode by default is always allow. I'm not aware of pretty much any Kubernetes cluster anywhere that uses that. In fact, most of them use RBAC and node together. But by default, it's let it all in. So if you started an API server, it has no authorization by default. It just allows anybody to come in. But fortunately, that's not typically what people do. Your bind address by default is listing on all interfaces, the directory where you can find certificates, the client CA string, all of these things, kind of make sense when you think about the way, what the response or what the API server is responsible for. You have the default wash cache size. So when somebody has a cache or a watch happening, the question becomes like how long does the API server cache a particular object as it relates to that watch, which is pretty cool. You've got admission plugins, and we're going to talk more about these. This is actually a really important thing to understand, because there's not one of the things that is a little frustrating about the API server, and I'm actually going to try and see if I can get this fixed myself in 2020. There's not a way for you to enumerate, according to these admission plugins, which admission plugins are enabled or disabled, right? What you can do is look at the command line options and see what they are, but there are some that are on by default and some that are not. And so if you wanted to see the default enabled ones, we do enumerate them here. These are all of the default enabled admission controllers that are defined within the API server. And if you wanted to add more of them, like if you wanted to turn on, for example, the node restriction, which is a way of restricting the node's access to objects that are stored by the API server, then you can also provide a list of things that you would append to that default list. So, pretty interesting stuff. The reason I'm calling this out is because sometimes it's difficult to determine whether these defaults have changed. And if they have changed, like how do you determine like which ones are enabled or not enabled? And really right now the most concise way is by looking at the command line options that were used when spinning up the API server to begin with. Other stuff the API server does, obviously it needs to talk to etcd, but there's some other interesting things here. For example, this etcd prefix string, right? You can do a thing, for example, where, yeah, I agree with you. And that's why I think that some of the, Suresh, I agree with you. And one of the things I want to work on in 2020 is actually extending the, what do you call that? config-z endpoint to include, oh yeah, we're going to talk a little bit more about admission plugins here in just a second. But it's not a stupid question. There are no stupid questions. So I want to extend the config-z endpoint to include things like configuration of all of those objects, not just the kubelet. And I'd like for it to actually have a way of describing the current configured state rather than just like a partial config that could be related to the configured state. But this is like one of the things I'm hoping to take on in 2020. Back to etcd. Etcd, and we're going to talk about this a little bit, but like you can actually describe multiple etcd clusters behind an API server and route different things to that, right? So if you wanted to, like, for example, have a different etcd cluster for events rather than all of the rest of it, like the registry, then you can actually bring up multiple etcd clusters and configure them according to these command line flags and have events sent to a different etcd cluster than you send all of the registry information to, which is pretty exciting because it means that as we think about how clusters scale, especially at large scale, we can think about ways to distribute the load depending on what we're actually hosting inside of that etcd, inside of that cluster across different etcd clusters, so that we're not, for example, like overwhelming one particular etcd cluster with event information. When we get up to like 1,000 nodes, we can actually separate the event data out and have the registry stuff not be held hostage by the IO required for events. Interesting stuff. Sorry about that. etcd uses MTLS, right? So when we're actually, so part of the configuration flags for etcd is to provide a client certificate that will be used to authenticate to etcd. And so there's some of the information that we can do, or some of the information that we can pull for. By default, the API server will compact etcd every 5 minutes. If you set it to 0, it won't. But yeah, there's tons of stuff configuring etcd, obviously. And then there's a bunch of feature gates for things that are relatively new or older, or things. And you can see what the defaults for all of them are here too, and especially as they graduate. We have, and I think this is also interesting, how do you only... It is really nice. And there are examples online for how to do that. I'm probably not going to explore that in this session, but if that's something you're interested in having a session on, go ahead and open an issue with the TGIK repo, and perhaps we could actually just do a session just on that. I think that would be great, if that's something you're interested in. We also have the API server needs to authenticate to kubelet. And I'm curious, I'm going to poll the crowd here, because this is an interesting one, especially if you think about the way that we normally talk about the API server. We talk about everybody talking to the API server. We talk about the API server talking to etcd, but we also have a few kubectl commands where the API server has to talk to the kubelet. And I'm curious, can my awesome audience list the kubectl commands where we have to actually have the API server authenticate to the kubelet to allow for some communication back to pods. Logs, exec, yep. Logs are definitely, and logs and exec are both. Kubectl proxy is a tricky one, actually. Kubectl proxy can proxy directly from the API server. It doesn't necessarily have to go through there. CP is another one, which we're going to copy a file in or out of a pod. Anything you have to actually interact with the pod level thing, those are calls that basically the flow for that call comes into the API server. Actually, you know what? There was a really great blog post. Let me see if I can find it. Kubectl exec, how it works. That was a great, I think it was this one. Yes, this is a great article. I'm actually going to put this in my notes. I should have put this here before. How kubectl exec works. A great article talking about exactly how kubectl exec works, and I think they did a great job of explaining it, because it does actually have to proxy through the API server and go back and talk to actually go and talk to a pod. Yeah, CP is mostly, it's true. I mean, like most things, logs aren't, but like a number of things are actually just wrappers around exec. Logs aren't, only because those logs are actually persisted to the kubelet. So the kubelet has, you still have to get to the kubelet to get to the logs, but those logs are actually persisted to the kubelet's disk, not inside of the actual pod itself. So, interesting stuff there. Port forward is a tricky one also, because you're, again, just proxying back to traffic that is going to terminate onto a pod, right? And so port forward isn't quite as simple as connecting to a pod through the API server. I mean, you are effectively doing that, but like you're using the API server to kind of just proxy that network traffic instead, right? Which means that you're not actually talking to the kubelet directly, right? You don't have to pass. Your traffic will pass to the pod, but it may not be like by proxying that traffic to the kubelet and then to the pod. It would actually just use like the internal implementation of proxy to do that. So other stuff, a bunch of other commands, and this is another big one. How do you, and we're going to talk about this here next, how do we authenticate to the API server? Some of the more common methods that I've seen involve OIDC, and we'll talk about how OIDC works here a little bit as well. Yeah. All right, enough time on the man page, but if you're interested, give that a read. And if you have specific questions, feel free to throw them into the chat. So, how does the API server authenticate to etcd? So we can see from the configuration of the kubelet node itself, right, that there are a number of flags defined here, right? And so because I'm actually running a single node cluster right now, everything is on the same node, I can see that my etcd servers are configured at 127.0.0.1.2.3.7.9, and that means that I have to make the assumption that the etcd cluster is local and that there's only just the one member, probably. Although if I do specify only one member, the other members will be learned if there are multiple members in etcd. There is vendored into the API server a fully fledged etcd client, right? So this isn't necessarily like just RESTful API calls to etcd. This is a fully fledged etcd client that is vendored into the API server, and that fully vendored etcd client is actually how it's going to interact with etcd. So we can see that we're expecting the etcd servers to be signed by some etcd CA cert, and we can see that our certificate, our etcd client certificate, has been given to us at a particular path, and there's our Keef, our Keef, our etcd client key, right? And so this actually gives us all the coordinates to interact with etcd, and this is how it's going to authenticate to etcd. Now the etcd cluster itself doesn't authenticate to the API server. It's kind of a one-way thing. The API server authenticates to etcd, but the etcd server does not authenticate to the API server. All of that in mind, because this is running as a pod, we can actually see the logs of the API server just by seeing the output of those logs, right? So because this is running inside of a container, I can see that container running here, and if we're curious about digging into the logs for those things, we can do CI-kettle logs, and we can take a look at what the log output looks like for a given cluster, right? So this is running 116.3. So it looks like some of the logs are actually kind of scrolled up a bit. But we can see kind of the starting up here, and we can see, in the log, we get information about like the mutating admission controllers that have been registered, and mutating ones that have been configured. And this means that these particular built-in admission controllers that have the ability to mutate an object have been registered. And then we have validating admission webhooks that have also been loaded in this particular order. And then we can go through like what else is happening, right? So we can see that we've got a connection error to etcd. Presumably, maybe it just wasn't up yet, but it came up after a time. And then we can just walk through the rest of the log and see what else is happening. We can see the caches are syncing. We can see the API server coming up and becoming available. We have the namespace condition controller loading up. There's all of the different controller logic that is specific to the API server is starting to come up. We have our OpenAPI aggregation controller starting up, and this is where if you're going to register different CRDs and those sorts of things, like how the API server knows that those objects are going to be aggregate is done through this object. We have priority class registering. We have the quota admission controller, or adding an evaluator for roles. We have a bunch of the other RBAC stuff kicking on. Looks like we're waiting for etcd to be compacted, but if you're in, and here are a bunch of other things like the quota admission evaluator for service accounts and deployments and daemon sets and leases and the lease coordination stuff. We're going to talk about that stuff as well. So yeah, I mean, this is a kind of a normal startup for the API server. And if you're interested in increasing the logs and like really digging into what's actually happening with an API server, obviously one of the things you can do, just like we did before in a previous episode, if you were to edit the Etsy Kubernetes manifests kube API server manifest itself and just add the flag -v, right? Then you could specify the verbosity of the logs provided by the API server. And so if that's something you're interested in digging more into or seeing more verbose logs with relation to the API server or even just one of the API servers in your cluster, that's one way that you can get that data back or increase the verbosity of logs. It does actually, yes. So the way that Kube API server is going to authenticate to etcd, it's going to, it's like, think of it like MTLS because it's pretty similar to that, right? I have a client certificate. I'm going to try and authenticate to etcd. etcd is going to return to me its certificate. I'm going to validate that the certificate provided to me by the etcd server is actually signed by that known CA. That's actually where the CA file comes in. All right, sorry, this one here. If it is, all things are good. If it is not, then I won't connect to it. And the same thing works on the other side, right? The etcd cluster is actually going to take a look at this etcd client that is being provided, the etcd client cert provided by the API server, and it's going to say, is that signed by a known CA? And if it is, then it will allow it access. But that's the extent of permission, right? etcd is not typically configured with any more granularity than that with regard to permission. As long as we have certs on both sides that are signed by known CAs, and in most cases, actually, even in this case, the CA is the same CA, right? So like the client cert and the server cert are both signed by the same CA certificate, and as long as we all agree on that CA certificate, then we're in good shape. I hope that answers your question, Bogdan. All right. Now, other things that the API server does, if we do cluster, I think this might have actually been deprecated, but I don't remember if it's actually gone yet or not. Could get all. Nope, still there, but it doesn't seem to be working terribly well. But kubectl get component status actually gives us the ability to kind of like interact with whether those things are working. I think this is deprecated now and it'll be removed soon. But there are other ways to get the API server to tell you about these things. So let's go back to our view here. We talked about how the API server authenticates to etcd. I want to also talk about other neat etcd tricks. So before I move on, so here's my kubectl get raw metrics grep etcd. There's a lot packed up into this, so I'm going to try and shrink this a little bit. That makes it a little easier to grok. So the API server is instrumented with Prometheus. And so if you're curious about digging into kind of like how the API server is doing with regard to that, there are a number of things that you have at your disposal that are reported by the metrics endpoint of the API server. And so some of the things that we can do are determine things like object counts, right? So we can actually look at the way from the API server's perspective, like how many objects are being stored in etcd. We can look at things like etcd request latencies. There's a ton of information that the API server instruments with relation to its interaction with the etcd cluster itself. And so if you want to understand more about the relationship between, or if you want to instrument better the relationship between your API servers and your etcd clusters, definitely take a look at the metrics that are exposed by the API server and also the metrics that are exposed by etcd directly. Both of them are instrumented with Prometheus, and so both of them are available to scrape with your Prometheus instance and to measure like latency responses and all of the other stuff as it relates to just understanding the care and feeding of the cluster. What's neat about the way this is instrumented is it's instrumented in a pretty complete way, right? Like you're getting latencies as it relates to things like config maps, not just the overall latency to the system, but also latency by path, right? And so we're able to see things like, is the latency to the events path creeping up? Are we starting to see the number of events overwhelm the ability for the etcd cluster to manage it as it relates to disk I/O, for example, right? So some of those metrics can be super helpful in understanding the care and feeding, the actual state of your cluster. You can get a lot of really good information there. So I just wanted to bring that up as cool etcd tricks. We talked about the API server has to authenticate to the kubelet. This is done by providing the API server a certificate, right? So if we go back into our cluster here, Kubernetes manifests kube API server, the API server is going to get its own client key to authenticate to the kubelet directly. And on the kubelet, typically, the kubelet will be configured to validate that client key is signed by some known CA. So a very similar pattern to the way that etcd works, right? So for example, if I look at my kubelet here, cat etc let's see, system ctl cat kubelet. I want to look at the kubelet config. So inside of my kubelet, I've got configured the X509 client CA file, and that is actually how I'm telling the kubelet to validate the. It's one of the ways that I'm telling the kubelet to validate that the incoming certificate request is to be trusted, right? So the way the API server typically authenticates to the kubelet will be using a certificate. And with that certificate, we're just making, on the kubelet side, we're just validating that the certificate is signed by some known CA, right? And then above that, we have this thing called webhook, where we actually handle things like, where we are able to validate things like tokens also, right? So if you had a service account token that had the right RBAC privileges to authenticate to the kubelet, then you would also be able to use a token to authenticate to the API server, to the kubelet. And we talked about some of these things back in the kubelet episode, so I'm not going to spend too much more time there. Okay. So that is how the API server authenticates to the kubelet. That's how it authenticates to the etcd cluster. Let's talk about how the other entities in the world authenticate to the API server. Because it's already almost 2. What do you got? Alibaba Crowd wrote a comprehensive blog. Yeah, exactly. Yep. That's a really good article, actually. I've seen that one by Alibaba. And there's another one that just came out talking about operating large clusters by something like Iron or something like that. I can't remember the name of the company, but yeah, if you look for articles on large clusters, there's definitely some really good ideas on how to do it. At the same time, personally, I think that we are better off operating smaller clusters, even with the added expense of being able of having to administrate them over time. for a number of reasons, but probably not going to dig into that here. All right, so authentication docs. Boop. How authentication works inside of Kubernetes. So this is a link to the docs for here, and there's a ton of interesting things that we can do with authentication inside of the API server, right? So typically, again, there's an option for the API server to just take anonymous authentication for things, and we can see that in the form of things like, oh, sorry, wrong button. If we do like curl HTTPS, get all config, view, minify, flatten. So this is our URL string for the API server. If I do this minus K, that is an anonymous API call. So I was actually I made a call to the API server with no authentication, and the anonymous API, allows me to do that because I have my healthy endpoint turned on. But what if I did v1, right? Then we can see that what I'm getting back from the cluster is that the user, system anonymous, since it doesn't know who I am, I'm not providing it any credential. It needs to be able to put me in some bucket. So it put me into system anonymous, and it can tell me that I don't have permission to do anything there, right? I cannot get the path of v1, and because I am forbidden to do so, and I get back a 403. So this is kind of exploring the authentication part of the API server. Now, for me to authenticate to the API server, I have a number of different options, right? I can authenticate with a certificate. I can authenticate with a service account token, a JWT. I can authenticate via OIDC, which is still using a JWT, just issued by some middleware. But fundamentally, these are the typical ways that one authenticates to the API server. There's also an authentication method in the Bootstrap token. So the way that kubeadm provides a Bootstrap token, that token can be used to authenticate to the API server as well, although it's generally locked down to just those actions that are required by Bootstrap. So let's explore those three ways of authenticating to the API server right quickly, and then we'll get into authorization, right? So first we're just going to explore authentication. So Docker CP So this is the admin.conf that is configured by the API on the API server on the control plane node when that particular node is brought up. And what I want to show here is that this is actually certificate authentication, and there's some interesting things about specifically how it works. So in this configuration, I've bundled into this kubeconfig, right, is the CA certificate. And that's necessary because this will allow me to understand, again, whether when I'm authenticating to the API server, is the certificate it's presenting to me as a serving certificate assigned by this CA, right? So this allows me to explicitly trust any serving certificate provided to me as long as they are signed by that certificate authority. So that's kind of the beginning of the trust relationship. When I call out to the server, and if I just were to do that, right? If I were to call out to that server directly today, right now, without anything else, I would see, well, just using curl, it says it was unable to validate that the certificate was issued by an issuer that we trust using the built-in certificate authority inside of my system. And so the way that we overcome that with kubectl is by providing a certificate authority data saying, if it's signed by this CA, then trust it. Next up, we have the client certificate that's going to be used to authenticate to the API server. And there's a couple of interesting things about it that I want to share with you just to understand the client certificate itself, the client certificate model, right? So I'm going to go ahead and dump this to base 64 minus D. And then I'll pass the output of that to OpenSSL X509 text. So what I've done here is I've grabbed the certificate from the client certificate data inside of my kubeconfig. I've decoded it using base 64. That left me with a certificate, and then I passed that certificate to OpenSSL so that we can look at how the certificate is actually configured. And there's some interesting stuff that happens here in the way that that certificate is encoded, which includes things like kind of providing hints around how we tie this certificate into RBAC. In certificate authentication to the API server, we look at these two fields, right? The subject organization and the subject client name. If the organization is system masters, then there is a group that's predefined within the API server as part of RBAC that provides system masters an incredible amount of access. And the client name, if I wanted to actually just associate a particular RBAC role binding or cluster role binding, I could actually bind that to Kubernetes admin. And as long as I'm using this certificate, common name, as long as I'm using this certificate to authenticate, then that common name will be the way that I can tie the authorization in as well. So certificates are interesting because encoded inside of them, in that subject line, right, is the way that it is enough information to represent how we're going to kind of provide hints or anchor the authorization aspect of this as well. And that's true of tokens as well, but we'll talk about that a little bit. Now, further down, we can see that this certificate is actually signed specifically for client authentication. I couldn't use this certificate as a server certificate, but this is kind of getting into some of the TLS stuff. Probably not really worth digging into in this particular episode, but interesting stuff nonetheless. Now, by default, and we talked about this before as well in the All of Your Certs Have Expired episode that happened earlier this year. By default, we issue a certificate on the cluster for 1 year for the admin.conf. But there is no revocation, right? So there's no revocation list for certificates that are issued by the CA, which means that when you issue a certificate leveraging the cluster CA, you're able to provide a certificate that will last a year, typically by default. And that means that if you wanted to, if that certificate becomes compromised, if somebody gets a hold of that certificate, there's no way for you to shut it down other than to change the actual certificate authority in the cluster. You can't just say that certificate that was the Kubernetes for that particular group is no longer viable. Right? There's no revocation list that is being watched. So keep that in mind when you're thinking about certificate authentication to Kubernetes. Certificate authentication in Kubernetes is a somewhat limited capability because you can't revoke them. Now, let's look at another one that's I think a little more interesting. I'm going to go ahead and create a service account here. And I'm going to create, associated with that service account, a role binding. So cluster role, create cluster role binding, test admin, cluster role, service account, default test. So what that does is it creates, I've created a service account called test, and I've created a cluster role binding the cluster admin privilege to the service account located in the namespace default that is named test. So the next thing I'm going to do is I'm going to use this create kubeconfig script just to generate a kubeconfig leveraging that token. So let's just do that real quick. And we can see what's happening here is I'm just leveraging the kubeconfig that I already have, and then I'm grabbing the token from the API server using the permissions that I have to replace the client certificate that I use to authenticate with a token. And this token is a JWT token, and this is the other way that we authenticate to the API server. Now, from the API server's perspective, the interesting thing about this token is whether the token is signed, not whether the token is valid. Whether the token, sorry. It is interesting that the token is, hold on. There we go. It's interesting that the token isn't expired, and it's also interesting that the token is, that some of these other fields are in here, including this one here, where we specify the KID, or the thing that signed it, right? And so this gives us the ability to validate that the signature of the token is signed by some known key. Does anybody know what key is signing this particular service account JWT? Pop quiz. Anybody know? So close. Nope. The SA.pub, the service account certificate, right? And that's it's a tricky question. But when you're configuring the API server and the controller manager, you specify what key will be used for signing the service account tokens, depending on whether you're using like an injected token or whether you're using the old style of service account tokens. And when you provide that, you want to provide the same SA pub and key, which is just a regular old certificate, RSA public key, right? But it's important that the API server and the service account and the controller manager agree on that key, so that when the API server tries to validate that a JWT token is actually signed by some known authority, it can validate that against this public key. So it's not the CA certificate; it's the actual S. We have a different key just for signing service accounts. Oh, you were close then. All right. So what's interesting about that, though, is it means that typically what that means is that when you're issuing a certificate, when you're issuing a token, some of the other fields that you can specify are things like expiry. So like if you're going to generate a token using an OIDC mechanism, like I don't know, like Google or any or Dex or any of these other tools, right? You can actually you can specify the expiry of that token, and when you do, then when that token expires, the API server will no longer honor it. But in our case, we can see we didn't specify an expiry, so this token will be as good as long as it lasts. Now, if I do kubectl get pods -a -kubeconfig -test, I can see that token exists, and I'm allowed to authenticate with it, right? But what's going to happen when I do this? This will be interesting. This is actually one of the things I like about service account tokens. Delete, secret, test. I'm going to delete the token associated with the service account. And as soon as I do that, and I do kubectl get secrets, I can see that the token has been regenerated. It's got a different like hash, but it's a brand new token. It's only 4 seconds old now. But now the token that I had in my kubeconfig is no longer viable because I deleted it in the cluster. So what happens if I do that get A again, right? It's still signed by a known authority, but we don't know it anymore. So this is how you can quickly revoke access to a cluster. If you have a service account token or an OIDC token some mechanism like that, and you're able to actually revoke that token, then you have the ability to actually, in an easier and more easier way, manage the access credential to the API server in a more revocable way. So cool. That's authentication for the certificate, for the token, and actually also let's just jump back in here real quick and we'll talk about Bootstrap token really fast. Cat Etsy Kubernetes. Docker exec TI. Okay. So in the tokens that are actually stored in Bootstrap tokens, and if we jump out here, we do kubectl get token dash a. Nope, it is still a secret dash encode system. So this Bootstrap token here, right? The Bootstrap token is actually stored in the kube system namespace as a secret. This token that is actually put in here, and its expiry and its token ID and all that stuff, it's actually just encoded. So if we did describe, I think it will decode it for us. Let's try that. Describe. There we go. Well, not quite, but you get the idea. So you can actually pull these things and decode them and take a look at them. But those Bootstrap tokens can be time-bound. They can talk about what their access is, and those tokens are used typically as part of the Bootstrap TLS mechanism when kubelets are trying to bootstrap the TLS authentication mechanism. So this token is typically used just to generate or to issue a CSR request against the API server so that the kubelet can get a signed serving certificate. Nope, client certificate, so that the kubelet can authenticate to the API server. And we talked about that in the kubelet episode, so I'm not going to spend any more time on that today. This is the kubeconfig token. Is this kubeconfig token is auto-approved for test user? No, well, only because as an administrator, I created it, right? So as an administrator, I created a new service account. When I pulled that token associated with that service account down, and then I used that as part of my kubeconfig. The SA key and SA pub do not expire. In fact, if you had all of the other certificates expire, those tokens, that token authentication mechanism would continue to work. Even though their certificates might have expired, the token itself would still work as long as it's still defined within the system and the API server can validate that that token is still there. So if your etcd client, if your etcd certificate expired, that would hit you, but the token itself would not. All right, let's get back into our list here. We talked about how authentication and authentication works. The kubelet components use different things, and I'm not going to get into it here in this session, but like the way the controller manager authenticates, I covered in the controller manager episode, and the way the kubelet authenticate, we covered in the kubelet episode. Go check those out if you're curious more about them. We've talked about the way that people and bots might authenticate, right? You can use service account tokens. You could use certificates, but I don't recommend it. You can use tokens that are issued by an OADC provider or a middleware solution. And the API server is just going to validate that that token exists, is currently valid, and that it hasn't expired before allowing admission, before allowing authentication. So that's the authentication piece from the API server's perspective. More information in the docs, and if you want to explore more of it, obviously, one of the things that we could really do to dig into it would be to bump the verbosity of the Kubernetes API server logs up, and then do things like issue tokens or delete them or try to authenticate One more thing before I go on here. I'm going to go ahead and regather that token. kubectl get pods -v10 kubeconfig. So we can see what's neat about the v10 thing is you can see this piece, right? And so what's neat about that is that you can see that when I am authenticating with a token, I'm actually using this authorization bearer mechanism to authenticate. I'm not using just straight certificate authentication. I'm actually using the token as a bearer token when interacting with the API server. So that's one thing. That's one of the other differences. So token is even materially a different way of authenticating to the API server than using a certificate. Using a certificate, we just basically say, we talk to the API server, we say, here is our client certificate. The API server pulls that open and looks at the organization and common name, and then proceeds from there. With the token mechanism, it's different. We have no client certificate to offer. So instead, we actually pass this as a bearer token, and the API server pulls that apart and says, is it expired? Is it signed by somebody I trust? Et cetera, et cetera. So different things. And this is true also of the OIDC token, right? When you're configuring OIDC, you're going to specify where to go find those signing keys, and you're going to specify the information about how the API server might go pull that middleware to determine whether the incoming token is valid or not, including what audiences might be encoded into the JWT token and all of that stuff. So that's just authentication, and it's already like 2:21. My goodness, people! We're obviously clearly not going to get through all of this, but we might. I suspected we would need multiple API server sessions, and I think we've proven so far that is true. Authorization docs. Let's go look at them. How authorization works inside of API server is really interesting. But this doc actually, I think, does a really decent job of explaining how it works. So yeah, it basically, once you have been authenticated to the API server, we go through a process to determine whether the request you made is allowed or denied, right? And so we can do that. We have a bunch of information to parse to determine that, right? We pull apart the request, and then we validate that against the user or group associated with that request and the RBAC rules that are the sum of permissions that particular user or group has when authenticating. And I'm pretty sure I've talked about this in the past as well, but there are a number of really great tools that allow you to interact with things, to explore the authorization aspect of the API server built into kubectl. So you have kubectl auth can I. So kubectl auth can I allows you to request whether allows you to interrogate the API server with regard to things that you may or may not be able to do, right? So if I were to do kubectl auth can I and I do -- list, as an administrative user, I can see exactly what permissions I'm given, right? And this one up here at the top is the big one, because it means that I have full access to do anything, right? But let's take a look at maybe a different service account that's within the cluster. So I'm going to do kubectl get sa-n kube system. Actually, let's just do default. So we have our test user, which is another administrative user, but let's look at the default service account that is given to every pod. What can that service account do, right? So I can do kubectl auth can I -- list as system service account default. So this is a way of actually validating or understanding what permissions or scope of permissions have been granted to a user based on some identifying characteristic of that user, right? So like in this case, it's a service account, But if you had that user's name, you might be able to do as that username or as group. There's another option there. Um, but this gives us the ability to explore like exactly what that particular entity can do, what permissions have been granted. And this is a really good, clear way of understanding from the RBAC perspective what permission you have. So we can see that the default service account has things like the ability to create self-subject access reviews and rules reviews, which is actually the mechanism that we use to see this output. They can do things like get APIs, they can get health checks, they can do get lives, they can get the open API spec, and they can get readies, and they can get version, but there's not much they can do, right? They can't create pods or create namespaces or do anything else like that as a default user. They can just kind of interact with the cluster on a discovery level and see like, is it healthy? Are things working? What version is it? What are the APIs that are exposed? Those sorts of things. Other things in the authorization piece, we talked about this when we talked about the kubelet, but one of the other authorizers that in kubeADM we enable is called node authorizer, and that node authorizer is documented here inside of the docs, and I have a link in there. But it basically, node authorizer allows a kubelet by its identity to access specific read operations and write operations, only as they relate to that node. And the good thing about this is it means that we're limiting the blast radius. If somebody gets a hold of a kubelet certificate, they won't be able to use that kubelet certificate to exploit the cluster. They can really only use it to interact with things that are specific to that node. Which is pretty cool. All right. We talked about authorization. Admission control. Think we can get through admission control in this next piece? Yeah, let's try it. And actually, no. It's 2:30. I'm going to stop here. I'm going to come back and explore all the rest of this stuff in the next time, in our next episode on the API server. So this is V1 of the API server. I had a strong suspicion that we would not be able to get through it all in one episode, but it is what it is. We will revisit this in the new year, probably after episode 100. So I think I mentioned this at the beginning of the episode. Episode 100, we really have some cool stuff planned. We're going to, I'm looking forward to seeing how it materializes, but our goal is to have a very special episode 100. It will happen on January 10th. It is not going to happen like next week. It's going to be, we're going to take a break over the holiday. We're going to come back on January 10th and do the next episode of TGIK. And I hope that you are all able to attend. It should be really super fun. Thank you very much for attending V1 of part one of a two-part Kube API server exploration. So far, all we've really been able to talk about is how we authenticate to it and how it authenticates to things. Obviously, there's a bunch more to talk about. So, thank you. I look forward to doing a lot more of the exploration of the API server next time. Y'all have a great weekend and a great holiday break. And there's a ton of content out there to just study up on. Thank you. I'll see you all next time. All right. Bye, guys. Bye, everyone. I don't mean guys. I mean bye, everyone. So see you all next time.